Okay, hi again. One more time. We are finishing up the chapter 1 notes. We're starting here at the bottom of page 6 and we will be finishing up the notes here on page 7. So there are other types of studies other than controlled experiments. Now remember always that controlled experiments are the only thing that can show causality. Does one variable cause another to happen? There's other types. So I don't know if it's really a study, but in your book, the author talks about this as sort of a study. Anecdotal evidence. That just means some story that somebody's telling based on someone else's experience. Okay. An observational study is something that we often do in statistics, but we can't use it to show causality. It just means that we have subjects placed in different groups by choice or someone else who is not involved with the study, and we're just observing what is happening. We didn't try to show there's causation because we didn't randomly assign to a treatment group and a control group, etc., etc. So, caution. Anecdotal evidence and observational studies never point to causality, cause and effect. They only point to an association or relationship, some people will say, or a correlation between variables. So a correlation can be shown between variables. They're related. We just can't show one causes the other or not. To establish cause and effect, whether one variable caused another to happen or not, we must use a controlled experiment. So for example, if you notice that when there are long lines going to the beach, the number of ice cream sales go up. Does this mean that the long lines to the beach caused an increase in sales? Hopefully you should quickly say no. We're just observing that. We're just observing that there are long lines going to the beach, and that's correlated with the number of ice cream sales going up. Do we know that the long lines cause the ice cream sales to go up, or the ice cream sales going up cause the long lines? No, we don't. We're simply observing. That's called an observational study. When we do an observational study, there are confounding variables that are not accounted for. That a confounding variable is a variable that has not been accounted for, but which is causing or could be causing a difference in the groups being studied. For example, possible confounding variables in that previous example of long lines and ice cream sales going up at the beach could be that it's hot outside. It's hot, so more people are buying ice cream. Or there's a sale on ice cream, so the cost of ice cream is low for some reason, etc. You could probably think of numerous other confounding variables that could be affecting this rather than just lines and ice cream sales themselves. Okay, so when we're doing experiments, when we do a controlled experiment to try to show that there's causality, there's also what's called the gold standard. Okay, and the gold standard we'll talk about as time goes on through the course, but we need to have a large sample size. That will help us cut down on our variability. And remember, variability means differences. We want to just understand our differences. We don't want to have differences that are really not representative. So how do we do that? We look at a large sample. And the assignment to the treatment or control group is random. It's controlled by the researcher. In other words, it's not by chance or already placed in groups. And if possible, we want to use a placebo if it's appropriate. Study is double blind. So not only do the researchers, not only do the patients or people being treated, whatever the treatment is, not know if they're getting the treatment or not, the researchers also don't know who's getting the treatment. So when you see statistics and news, what I really want you to get out of chapter 1 is the following. You should always ask yourself a few questions. Did they show me an observational study, or did they give me the results of a controlled experiment? Remember, observational study, no causation. Controlled experiment, okay, they can talk about one causing the other. For controlled experiments, did it meet the gold standard? Okay, the gold standard, remember, was you have to have it controlled. Go back up here. Has to be a controlled experiment. Has to be a random assignment. Has to be blinding. I'm sorry, the gold standard. Gold standard, large sample size, random, controlled, placebo, and double blind. And was the paper published in a reputable peer-reviewed journal? Peer-reviewed means that other people, experts in the same field as those publishing the paper, have reviewed it and sort of guaranteed its authenticity and the fact that it was well done. And lastly, did they follow people for a long time? Not just a quick snapshot, but as a long time taken into account. And that's the end of chapter 1.